All right, let's talk about testing. Ever feel like your unit tests are, well, just kind of there? You write them, they pass, you move on? Today, we're going to blow past that. We're not just talking about the basic syntax of xUnit, we're diving deep into the senior level thinking that turns a decent test into an absolutely rock-solid one. So let's get into it.
Okay, first question, and I want you to be honest with yourself here. Do you copy-paste your tests? You take one, duplicate it, change a value or two, and boom, new test. We've all done it, right? But here's the thing. That little shortcut is actually a massive red flag. It's a sign that there's a much smarter, much more powerful way to get the job done.
And here is that smarter way. This is a senior level insight that'll completely change your approach. If you find yourself about to copy-paste a test just to change the input data, stop. That's your cue to use a theory. This is like the first major unlock to writing way more efficient tests.
So, that little rule of thumb brings us right to our first big decision point every time we write a test. Are we dealing with a fact or a theory? And trust me, this isn't just about picking one attribute over the other. It's a strategic choice. It's about understanding the fundamental purpose of the test you're about to write.
At a super high level, the difference is pretty simple, right? A fact, well, it runs once. It's a one and done deal. A theory, though, that's your workhorse. It's designed to run over and over again with different data. You can think of it like this. A fact is like a sniper shot, testing one very specific thing. A theory is more like a machine gun, hitting your code with everything you've got to make sure it can handle the pressure.
Okay, let's break this down even further with this table. On one side, you've got fact. It runs once. Its input is totally fixed, hard-coded right there in the test. The use case? Super simple, isolated scenarios. Then you look at theory. It runs multiple times. Its whole purpose is to take in dynamic input. This is your go-to for data-driven testing for when you need to check a bunch of different cases all at once.
So, when do you actually reach for a fact? Think of it like a precision tool, like a surgeon's scalpel. You use it when you're testing one single, specific scenario. There are no what-ifs. The inputs don't change. You just need to verify that for this one specific setup, you get this one specific result. That's it.
And a theory? Well, that's the opposite. That's your heavy machinery. You roll this out when you need to really put your code through its paces. It's perfect for when you have a whole range of inputs to test. And more importantly, this is how you cover all those gnarly edge cases, right? What happens with a null value, an empty string, a zero? A theory lets you test all of that systematically.
All right, so you've made your strategic choice between a fact and a theory. You've set up your test. Now what? Now we get to the absolute heart of the matter, the whole reason we're here, the assertion. This is the moment of truth where you actually check if your code did what you said it was going to do.
So what is an assertion, really? At its core, it's basically you, the developer, planting a flag and making a claim. You're saying, hey, when I run this code, I expect this specific thing to be true. And the test runner's job is to come along and say, yep, you were right, or nope, something's broken. It's the verification step. Now listen up, because this is a senior level rule that will save you so much pain down the road. Your assertions should test behavior, not implementation. Let me say that again, behavior, not implementation. Why? Think about it. Implementation details, the specific way you wrote a method, can and will change all the time. That's what refactoring is. If your tests are tied to those details, every little refactor will shatter your test suite. But if you test the behavior, the what it does, not the how it does it, your tests become resilient, stable, and 1,000 times more valuable.
Okay, we've got the what and the why. Now let's talk about the how. How do you structure a test so it's super clear and easy to understand? There's a simple, elegant pattern for this, and it's called arrange, act, assert, or just AAA for short. This is your blueprint for clean, readable tests. And honestly, it's as easy as 1, 2, 3. First, you arrange. This is your setup phase. You create all your objects, mock your dependencies, get everything ready. Step 2, you act. This is the main event. You call the one single method that you're actually testing. And finally, step 3, you assert. You check the result. Did the action produce the outcome you expected? Arrange, act, assert. Simple.
So why do we even bother with this? What's the big deal? Because it creates consistency. It creates a predictable rhythm. When you and everyone on your team follow the AAA pattern, anyone can look at any test and instantly get it. They'll know exactly where the setup is, what's being tested, and what the expected outcome is. This makes your tests incredibly readable and so much easier to maintain in the long run.
Okay, we have our core concepts, fact versus theory, we have our structure, AAA. Now let's add the polish. These are the pro-level best practices, the little details that really signal senior-level thinking and take your tests from just working to world-class.
So here are a few key habits you really want to build. First, keep your tests independent. Each test should be a world unto itself and not rely on another test running before it. Second, use meaningful names. Don't call it test 1. Call it calculate should return 0 when input is invalid. Be descriptive. Third, try to stick to one assertion per test. It keeps the purpose of the test crystal clear. And finally, and this is a big one, always cover your edge cases. Test for nulls, test for empty collections, test for invalid inputs. That's where the real bugs hide.
All right, let's bring this all home. Why does this stuff matter? Because these aren't just abstract concepts for a textbook. This is the stuff that separates the pros from the amateurs on real-world projects. And yeah, it's also exactly what they're looking for in a technical interview. When you can talk about this stuff intelligently, you're not just showing you can write code, you're showing you can write high-quality, maintainable, professional-grade code.
And because you understand all this, you now have the superpower to spot common mistakes from a mile away. You'll see someone using a fact where they should be using a theory for multiple cases, and you'll know why it's a bad idea. You'll see a test with 10 assertions and recognize that it's trying to do way too much. You'll see someone trying to test a private method and know they're testing implementation, not behavior. These anti-patterns will just jump out at you.
So let's put you on the spot for a second. Imagine you're in that job interview, the pressure's on, and the interviewer leans forward and asks, so, tell me, what's the key difference between a fact and a theory in xUnit? You're not going to stumble, you've got this.
And here it is, your one-line, gold-plated answer. You look them right in the eye and say, a fact is for a single, specific scenario, while a theory is for data-driven testing across multiple scenarios. And in both cases, assertions are used to validate the code's expected behavior. Boom, done. That single sentence proves you get the strategy, not just the syntax.
So, I'm going to leave you with a challenge. The very next time you sit down to write a test, or maybe when you see that block of copy-pasted tests in your code base tomorrow, how are you going to refactor it? You now have the mindset, you have the tools. You know what separates a basic test from a professional one. So go on, write some truly amazing tests.